Welcome back. Let's pick up with example 3. We're going to write an absolute value function. This time we're going to get the information from the graph shown and we're going to write the equation. So our equation is going to be in the form y equals a times the absolute value of x minus h plus k. Alright, so the vertex of the graph, that's going to be the first thing we figure out, is 3, 2. So that means h is 3 and k is 2. So we substitute those values into our equation. And so we have y equals a times the absolute value of x minus 3 plus 2. So we have values for 2 of our parameters, our h and our k. Our third parameter, a, we still need to know. So what we're going to do is we're going to take one of the known coordinates. We're going to take the x value, substitute that in for x, the y value, substitute that in for y, and then we're going to solve for a. So we're going to substitute the coordinates of the point 1, negative 2, because that's a point given to us, into the equation and solve for a. So negative 2, that's the y value, equals a times the absolute value of 1 minus 3. And then we have plus 2 at the end. And so when we solve for this, we get negative 2 equals a times the absolute value of negative 2 plus 2. We subtract 2 from both sides and get negative 4 equals a times 2. And so we divide both sides by 2 and we get negative 2 equals a. So an equation for the graph is y equals negative 2 times the absolute value of x minus 3 plus 2. Okay, once you know a, h, and k, you're done. That's how you know you're done. So the process is you substitute in for h and k, then you find a specific x, y value, and you plug those in temporarily just so that you can solve for a. Okay. So, transformations of general graphs, again, are gonna, just to review, are for any graph. This certainly worked for our absolute value functions, but it works for any function. The graph of y equals a times f of x minus h plus k can be obtained from the graph of y equals f of x by performing these steps. For step 1, you're going to stretch or shrink the graph of y equals f of x by a factor of absolute value of a if absolute value of a is not equal to 1. If absolute value of a is greater than 1, we're going to stretch the graph. If absolute value of a is less than 1, you're going to shrink the graph. We're going to reflect the resulting graph from step 1 in the x-axis or across the x-axis if a is less than 0. So if you have a negative there, you're going to flip it across the x-axis. And you're going to translate or slide the resulting graph from step 2 horizontally h units and vertically k units. Alright, so here what we're going to do is we're going to apply transformations to a graph, just kind of a generic graph. The graph of y equals f of x is shown, and we're going to sketch the graph of the given function. So we're going to use the points that they give us, 0, 4, 1, 1, and 4, 3, along with the general form of the graph. We're going to use that, and then we're going to apply the transformations to them, and that's going to help us sketch our picture of the transformed function. So the first one we're going to look at is y equals 1/2 times f of x. So the only transformation here is that it needs to be shrunk by a half. Okay, so let's look back at the last slide. You check your stretching or shrinking, you check to see if you need to reflect, and then you see if you need to slide. So you stretch, reflect, slide. That's another way of saying translate. Okay, so looking at part A, all we need to do is stretch, which is actually a shrink because it's 1/2. We're going to squish it down by a half. So the graph of y equals 1/2 f of x is the graph of y equals f of x shrunk vertically by a factor of a half. To draw the graph, multiply each y coordinate of the labeled point on the graph y equals f of x by 1/2 and connect their images. So 0, 4, I multiply the 4 by a half and I get 2. So I plot the point 0, 2. For the point 1, 1, I multiply the y coordinate by a half and I plot the point 1, 1/2. And then finally for the point 4, 3, I multiply the 3 by a half. So I plot 4 3/2 or 4 1.5. And I get the 3 points you can see here, and then I just draw in the line segment from 0, 2 to 1, 1/2, and then I draw in the ray starting at 1, 1/2 that goes through 4, 1.5. But what's critical is that you apply the transformation to the individual coordinates. And actually, to be technical there, the y value of the coordinates, because y equals 1/2 of f of x. Y equals 1/2 of the original y value. Okay, now the next one's got a little bit more going on. The graph of y equals negative f of x minus 1 plus 2 is the graph of y equals f of x reflected across or in the x-axis, then translated right 1 unit and up 2 units. Okay, so the thought process is you check for a shrink or a stretch or shrink, then you check for a reflection, and then you see if you need to slide or translate. So there's not any stretching or shrinking, okay, because the coefficient in front of the f of x is just -1, so there's not going to be rescaling in that manner. And because there is a negative, we do want to reflect across the x-axis. And you may have learned that earlier is flipping. Same thing, you're going to flip across the x-axis. And then you're going to move to the right 1 unit because h is 1. Remember, the form is x minus h. So h itself is positive 1 and up 2 because it's plus k. So since we've got plus 2, you would move up 2. To draw the graph, first reflect the labeled points and then connect their images. Then translate and connect these points to form the final image. Okay. Let me just kind of talk you through it here. So we would take 0, 4, and we reflect that down to 0, -4, okay? And then you move it right 1 and up 2, and that gets you to this point right here of 1, -2. Then you take the point 1, 1, and you flip it over, reflect it across the x-axis to 1, -1, and then you go right 1 and up 2. Let me find my little cursor again. Here we were at 1, -1. We go right 1 and up 2 to the point 2, 1. And then finally we do the same thing with this little guy over here. At 4, 3, we reflect it down to 4, -3. And then we move right 1 and up 2. And then you connect the dots. Okay, you do the ray for the first portion, line segment for the first portion and the ray for the second portion. So take it one step at a time. The way I do it is I take each point and I go through the steps. Okay, if they needed to stretch, I would stretch them. This one didn't need a stretch, so I just moved to reflect and then translate the way that it needs to translate. Slide it the way it needs to be slid. In this case, right 1 and up 2. Okay, and with practice, it'll get a lot easier. So go ahead now. It's time for you to practice a couple of problems. Make sure you try them, and then when you get to class, we'll go over them, and I'll answer any questions you have, and then you'll get plenty of practice doing the rounds. I will see y'all in class. Have a good day.